2.3 is chemical names and formulas, and this is in Chapter 2 of our Science Connect 1 textbook. So, to communicate with scientists around the world, IUPAC established a standard way of describing chemicals, so a standard way of symbols and names. Regardless of where you are on this planet, whether you are in Japan or you're in Greece or you're in Mexico, every chemist will communicate carbon, for instance, as C, and they will write it as carbon. Okay, so the standards help because C, or however you would say carbon in so many different languages, would look different, and how you would write this letter could be different in whatever country you're in. So IUPAC is the International Union of Pure and Applied Chemistry, which you'll never need to remember, but it's this organization that dictates the rules on how you name things in chemistry, so that if we were talking to somebody elsewhere in the world, we would still be able to talk about the same things. Okay, so the first thing that they did was they made standard symbols for every element. Every symbol is either 1 or 2 letters. The first letter must be a capital. The second letter must be lowercase. So for instance, we have carbon and oxygen. Carbon being just a capital C, oxygen being just a capital O. Now, some elements have 2 letters. If that's the case, the first letter is still capitalized. The second one has to be a little letter. So big C, little o is cobalt. Now note that if you mix up your capitalization and maybe you wrote C and a capital O, it means carbon monoxide, meaning that there is a carbon and an oxygen coming together to make a compound, not cobalt. So be careful when you are writing this. Most make sense with the element's name, however, some are different. So, for instance, silicone is Si, bromine is Br, argon is Ar, calcium is Ca. All of these seem to make sense, but we look at some and we wonder, how on earth did they come up with this element symbol for this name? So, for instance, Pb is lead. Well, Pb in Latin was plumbum, and so lead used to be known as plumbum. It was used in plumbing, lead pipes, so they kept Pb. So they didn't just use the English version. They used a lot of Latin names as well. Au is gold. Au is for, I think, aurum. Because gold, of course, is nice and bright and sunny. Again, a Latin word. Sn is tin, and it stands for stannum. Again, an older Latin name for the element tin. Okay, so some of them are intuitive, and some of them we have to actually look them up or remember that they're a little bit funky. Chemical formulas. So for example, here I have the chemical formula of carbon dioxide, or CO2. So breaking down the formula here, C, we know because it's the first element and the next element isn't a little element, I look up just C on my periodic table and I find that it is carbon. There's only one carbon because it doesn't have a little subscript or little number below it here. Okay, so there's only one. If there's only one of something, it's like in math, we don't write 1x, we just write x. So we don't say we have C1, we just say we have C. Oxygen is next, it's the next capital. Oxygen there are 2 of them in this compound because we've written it as O2. So there's 2 atoms of oxygen here because it has this subscript of 2. Now in brackets at the very end here is the state of matter. So the state of CO2 is a gas because there's a G in the brackets. Remember, our states are a gas, a liquid, which is typically, if you're handwriting it, you would write it with a curly L. If you're typing it, that's fine. We use little or under lowercase letters, sorry. And our last one is, of course, an S. So a small s stands for solid. So describe the compound represented by this formula. So I wanted to break down a few more for you. So NaHCO3. N is capital. The little a tells me that this belongs together. Remember, little letters can follow a capital. So Na is sodium. And how many sodium atoms are in this compound? There's only one atom, because there is no subscript. Remember, we assume then that there's only one. Next up is H. H is hydrogen. Again, there is no subscript, so we know that there's only one atom. Next up is C. C is carbon. There's only one atom of carbon. And last but not least is oxygen, O. Because there are three, we know there are three atoms. There's three because of the subscript below. And last but not least, the state of this compound is a solid in this case because of the S. I think you could do H2O2 on your own. If you pause for a moment, you should find that there are 2 hydrogens, 2 oxygens, and its state is a liquid. I just want to go over this challenge one that I've included here. I can see that there is a carbon, and there's 2 atoms of carbon. I can see next that there's a hydrogen. But if I look a little further on, there's also another hydrogen. So how many atoms of hydrogen are there total in this compound? Well, in total, there was 5 from here and 1 from the end. Remember, there's no subscript. We assume it's a 1. Therefore, there are 6 atoms of hydrogen total. It just is written differently where we have hydrogen in 2 different spots. That is totally possible. And last but not least, there is an oxygen. There is only 1 atom of oxygen in this compound. We get back to a hydrogen, which we've already accounted for. We are done. The state of this is a liquid because of the L in brackets. How many atoms are there total in this compound? In total, there are 2 plus 6 plus 1 atoms. 2 and 6 is 8, plus 1 is 9 atoms total. A little bit of practice for you. There's a table in the Interpreting Chemical Formulas activity that could be helpful, and a little bit of extra practice towards the end of that page.